Friends, in previous lecture, we discussed about the conditional convergence and absolute convergence of series. We have proved result that every absolutely convergent series is convergent, but not conversely. Means conditionally convergent series must not be convergent. Must not be convergent. Okay. Now, in this lecture, if we have series of numbers contributing positive numbers as well as negative number, then we'll express that sequence as addition of positive number sequence series and series of negative numbers, and with help of that we'll discuss its convergence. Okay, so let summation of n equal to 1 to infinity be series of real numbers. Define Pn is equal to let Pn is equal to An if n's are greater than 0 and 0 if n's are less equal to 0. That is Pn is equal to maximum of An 0 and Qn is equal to An if n less than 0 and 0 if n greater than equal to 0. That is Qn is equal to minimum of n0. Okay. Then 2 times Pn is equal to n plus mod n for every n. For example, if n's are positive, then mod n is same as n plus n will become 2n. And if n's are negative, then this n is a negative and mod n it's positive number. So their addition will become 0, Pn becomes 0. Okay. And 2Qn is equal to An minus mod n. Okay. If An is a negative number, then this n is itself. This mod n is nothing but minus of n, minus become plus. N plus n will become 2n, and if it is a positive number, n is positive, then mod n is n itself. N minus n is 0. So your Qn is 0, 2 times Qn is also 0. 2 times Qn is 0. And An is equal to Pn plus Qn for every n. So if n is positive number, then your Qn n is positive number. Then your Qn is 0 and n takes Pn value. If n is negative, then n is equal to Qn and Pn is 0. Is it clear? So, and if n's are zeros, then Pn Qn is 0 and n is equal to Pn plus Qn. So, in any case, we are getting these relations. So with help of this, we'll prove result that theorem. If summation of n converges absolutely, if summation of n equal to 1 to infinity converges absolutely, and Pn is equal to maximum of n0, Qn is equal to minimum of n0, then summation of Pn and summation of Qn converges. Then summation of Pn and summation of Qn n equal to 1 to infinity converges. So for series summation of n equal to 1 to infinity, Pn is equal to maximum n0, Qn is equal to minimum n0, which implies 2Pn is equal to n plus mod n, 2Qn is equal to n minus mod n, and n is equal to Pn plus Qn for all n. Now since summation of n converges absolutely, implies summation of mod n and summation of n are convergent series. Therefore, sum of addition of convergence, sum of convergent series is convergence, implies sum of n plus summation of mod n, which is equal to summation of n plus mod n is equal to summation of 2Pn equal to 2 times summation Pn is convergent, and therefore half times 2 summation Pn equal to summation Pn is convergent. Okay. Similarly, summation n minus summation mod n is equal to summation of n minus mod n, which is equal to summation of 2Qn is convergent, and therefore half times 2Qn is equal to summation of half into 2Qn is equal to summation Qn is convergent. Okay. Thus result is proved. But now if that series converges conditionally, then summation Pn and Qn diverges. Okay. B, if summation of n converges conditionally, Pn is equal to this, then this series diverges. For series summation n, Pn and Qn are defining this, 2Pn, 2Qn, n's are defining this, converges conditionally, This implies summation of n is convergent, but summation of mod n is divergent. Is divergent. n is divergent. Now, if Pn is divergent, summation of Pn is divergent. Okay. Now, if summation of Pn is divergent, then convergent, then summation of 2Pn is convergent, and therefore summation of 2Pn minus summation of n is equal to summation of 2Pn minus n, which is equal to 2Pn minus n is nothing but mod n is convergent. This is contradiction to, this is contradiction to summation mod n is divergent. Therefore, summation Pn is divergent. Similarly, if summation Qn is convergent, summation Qn is convergent, then summation of n minus summation of 2Qn is equal to summation n minus 2Qn is equal to, this comes to be summation mod n is convergent. Is convergent. Is it right? This is contradiction. This is contradiction. Therefore, summation of Qn diverges. Okay. So, here we proved that if summation of n is absolutely convergent series, then summation of Pn and summation of Qn converges, while if summation of n converges conditionally, then summation of Pn and summation of Qn are divergent series. Are divergent series. Okay. Now, we will take examples from exercise 3.4. Exercise 3.4. Classify as divergent, conditionally convergent, or absolutely convergent. As convergent, divergent, conditionally convergent, or absolutely convergent. In that 1 minus 1 upon 1 factorial and so on. So, for this alternating series, If I take this as summation of minus 1 raised to n plus 1 upon n factorial n equal to 1 to infinity. Summation of mod of minus 1 raised to n plus 1 upon n factorial is equal to summation of 1 upon n factorial n equal to 1 to infinity. Is convergent. Is convergent series. It's convergent series. Okay. We are going to help how it is convergent. Okay. And therefore, given series converges absolutely. And hence convergent. Second, if I take 1 minus 1 by 3 plus 1 by 5, 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus dot dot etc. is alternating series such that 1 is greater than 1 by 3 greater than 1 by 5 greater than dot dot etc. and limit n tends to infinity of 1 upon 2n minus 1 is equal to 0. Therefore, if I compare this as summation of minus 1 raised to n plus 1 upon n, is alternating series such that, therefore, given series is convergent. Is convergent. Now, summation of mod of minus 1 raised to n plus 1 upon 2n minus 1 n equal to 1 to infinity is equal to summation of 1 upon 2n minus 1 is a divergent series. So, we will discuss the convergence and divergence of these series with help of ratio test, root test or some other concepts, limit form of comparison test, etc. Okay. And therefore, summation of minus 1 raised to n plus 1 upon 2n minus 1 n equal to 1 to infinity is conditionally convergent series. Conditionally convergent series. Third, one half minus 2 by 3, 1 half minus 2 by 3 plus 3 by 4 minus 4 by 5 and so on. This is equal to summation of minus 1 raised to n plus 1 into n upon n plus 1. Its alternating series such that limit of n tends to infinity of n upon n plus 1 is 1 not equal to 0, and therefore limit n tends to infinity of nth term n plus 1 into n upon n plus 1 doesn't exist, and therefore by necessary condition of convergent series of convergent series, summation of minus 1 raised to n plus 1 into n upon n plus 1 diverges. This series is divergent. Now there is one question that can a series of non-negative numbers means series of positive numbers converges conditionally. So for that series of non-negative numbers, if summation of n is series of non-negative numbers, means n's are greater or equal to 0. So mod n's remains n's. So summation of mod n is equal to summation of n. Is it right? So it is impossible that summation of n is convergent and summation of mod n is divergent. So some series of non-negative numbers can't converge conditionally. Can't converge conditionally. Okay. So with this discussion, we'll stop our lecture here. Thanks for listening lecture carefully. Bye bye.